Hello there, ladies and gentlemen. This is the lecture for section 4.1, Sample Spaces and Probability. Now, sample spaces sounds very mysterious, but we'll define that in just a moment. It's basically just a set. And probability, I've already discussed, is a little bit harder to define than you might expect, but we're going to have a working definition. Basically, it's just the likelihood or the chance of something happening. So it's very easy in our everyday life to figure out what we're saying, but it's not that easy to make a good, solid definition. Okay, so first thing we talk about is just this idea of basic concepts. In my opinion, it's very useful for you to have in your mind for every single concept that we deal with, every definition we use and so forth. It's very helpful if you have an example in your mind that makes sense to you and that is of interest to you. Most of us are not that interested in flipping a coin. Most of us are not that interested in just rolling a die. Okay. However, these examples are to help us understand the concepts. The work that you will do in the future in a different class in physics, medicine, what have you, those problems will be much more interesting. So it's just a matter of we're going to use examples that are not particularly exciting, not particularly interesting, but they illustrate the concepts. So don't think that probability is not very interesting just because the examples that we use are not particularly interesting. So take my word for that. I haven't lied to you yet. All right, so here's the basic concept. Certain processes, such as flipping a coin, or rolling a die, or drawing a card, we call those a probability experiment. What's the key here? The key is it's a chance process. In other words, we don't know what's going to happen. Now, when we throw a die, that's one of a. If you have two of them, they're called dice. If you throw one of them, it's called a die. If you throw a die, you know what's going to happen in the sense that it's going to be a 1, a 2, a 3, a 4, a 5, or a 6. But you don't know what's going to come up. Is it going to be a 2? Is it going to be a 3? And so forth. When you flip a coin, you know it's going to be a head or a tail, but you don't know what it's going to be. So we call that a probability experiment. An outcome is a result of a single trial of a probability experiment. Now that word single is important. An outcome is the result of a single trial. So if I toss the die one time, that is an outcome. If I flip a coin one time, that is an outcome. It's a single trial of this experiment. Okay, so I'll let you read this. Now we come up to this definition of sample space. It's the set of all possible outcomes of a probability experiment. Now remember, an outcome is a single trial. So here's some sample spaces. If the experiment is tossing one coin, what are the possibilities of tossing one coin? That's a single trial. The possibilities are get a head or get a tail. Roll a single die, the probability or the possibilities 1, 2, 3, 4, 5, and 6. Answering a true, false question and so forth. So you can kind of see what's going on here, right? Let's say you toss two coins. Well, now, if you're tossing the two coins, in a sense, you're tossing them at the same time, even if you do one after another. That's a single trial. So tossing two coins is still considered an outcome. It's a single trial of a probability experiment. So what can you get when you toss two coins? You can get a head. So Joe does it and Billy does it. So Joe and Billy, each of them toss the one coin each. So Joe and Billy. So Joe gets a head, Billy gets a head. Joe gets a tail, Billy gets a tail. Joe gets a head, Billy gets a tail, and so forth. You see how that works, right? So don't be confused. It's one experiment. It's one outcome. Is a result of a single trial. So it's a single event there, okay? Or excuse me, single outcome. The reason I corrected myself is because so often when we're talking, what we'll do is we'll use the word outcome and we'll use the word event. And it's very confusing, and you'll see in just a second how we define the word event. An event is not the same as an outcome necessarily. It can be, but an event, it has a particular definition. You'll see here in just one second. So here we go. This is an experiment rolling a dice, rolling two dice, two die. I wish they would fix the language on that. All right, so do you see what's going on here? Each of the die can land in 6 different ways, and 2 dice are rolled. So the sample space, we're going to write it like this. We have die number 1, die number 2. Or you could say the red die and the blue die, however you want to say it. You do it 6 times, and as you can see, die number 1 has 6 possible results, okay? An outcome is the result of a single trial. So if you roll die number 1, the result can be a 1, 2, 3, 4, 5, 6. Die number 2, the result can be 1, 2, 3, 4, 5, 6. Now these guys in here, you see where we have these numbers with the parentheses, those are called ordered pairs. Ordered, O-R-D-E-R-E-D. Ordered means it makes a difference which of these components that you're looking at. So for example, right here, 3, 2, 3 corresponds to die number 1, 2 corresponds to die number 2. Over here, 5 corresponds to the first die, that's die number 1, and die number 2 is the 4. So they're ordered. It makes a difference. The order makes a difference in this ordered pair. So these are all the possible outcomes. So since this is a depiction of all of the possible outcomes, we refer to this as the sample space, because up here we said a sample space is the set of all possible outcomes of a probability experiment. Okay, now here's another. Let me take a little break here. All right, so we talked about the dice. Now we're going to talk about drawing cards. Now, hopefully everybody is aware that when you're drawing cards, there's 52 cards. There's 4 suits. You got the hearts, the clubs, the diamonds, and the spades. Okay, everybody knows this, I hope. Here's hearts, here's diamonds, here's spades, here's the clubs. The hearts and the diamonds are red. These other guys are black, obviously, okay? So there's 52 possible outcomes. When you pick a card, you could get a 4 of diamonds, you could get a 4 of hearts, you could get a 6 of spades, you could get a 10 of clubs, and so forth. So these are the outcomes. So the sample space, again, looking back on our definition, is the set of all possible outcomes of a probability experiment. Okay, so far not too exciting, right? Gender of children. Find the sample space for the gender of children. If a family has 3 children, B for boy, G for girl. So you have 3 kids. You have boy, 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 girl, etc. Girl, boy, boy, and all that. Okay, so now those are the possibilities. We'll see in a little while, how do we count these? How do we decide that there's 8 possibilities? Well, there's 3 events. The first kid, second kid, and I'm sorry, I shouldn't say events. There are 3 experiments, I should say, and the experiment is the woman giving birth. So out of those 3, there's 2 possibilities out of the first experiment, 2 possibilities out of the second experiment, 2 possibilities out of the third experiment. So it's 2 times 2 times 2. That gives you the 8. So out of this first one here, you could have had a boy or a girl. The second one, you could have had a boy or a girl. Here, you could have had a boy or a girl. So it's 2 times 2 times 2. Okay, so in these examples that we've just done, they're very simple examples, so we can find these examples very readily just by observation and by reasoning, by thinking about it. Another way to find, though, is for more complicated situations, is to use what's called a tree diagram. And here's the definition. It's just it's a device, or it's a way of figuring this stuff out using what are called line segments. So a line segment, this is a line segment. A line, as you probably know, goes on forever. A segment is a portion of the line. So that's why we're calling these line segments. So the line segment, emanating means coming from. So the line segment emanates from a starting point, And there's also a line segment that comes from the outcome point. It is used to determine all possible outcomes of a probability experiment. So let's go back to the kids. So you have the first child, okay? What could possibly happen? On that first child, you have a boy or you have a girl. After you have the boy, what could you have after you have the boy? You could have another boy or you could have a girl. Okay, do you see that? So the first outcome here is the first child, then you have a second child, then you have a third child. So I hope these are reasonably clear what's going on here. It's just a way for us to observe the possibilities and to organize our thoughts. And that's very simple for boys and girls, but when you start getting into more complicated situations, believe me, you're going to be glad you know how to use a tree diagram. So make sure you know how to use these things. Okay, so now, as he says before, an outcome is the result of a single trial. A single trial. You flip a coin one time. In many problems, you must find the probability of two or more outcomes. And so for this reason, we need to make a distinction. We distinguish between an outcome and an event. So an event consists of a set of outcomes of a probability experiment. Now, here's the thing though, okay? It can be confusing. An outcome is always one experiment. An event is a set of outcomes. Is it possible to have an event that merely consists of one outcome? Well, sure. It doesn't say here, the definition doesn't say a set of two or more outcomes. It just says a set of outcomes. So that's what he's saying here. He says an event can be one outcome or more than one outcome. So if you roll a die and you show a 6, this result is called an outcome. It's the result of a single trial. Okay, so that's okay. You can say that. An event that only has one outcome, in this situation here where there's only one outcome, we call that a simple event. The event of getting an odd number when a die is rolled is called a compound event. Why? Because there's different ways. There's 3 ways that you can get an odd number when you roll a die. So if you just roll one die, that's called a simple event, and you stop there, that's a simple event. If you roll a die and you're saying, well, I want to know what is the event of obtaining an odd number. Well, how many ways can you get an odd number? You can roll a 1, you can roll a 3, you can roll a 5. So there's 3 ways of getting it. So there's 3 outcomes that you can obtain in order to satisfy the requirement of having an odd number. So we say that it is a compound event because there's 3 outcomes, and then we're saying 3 simple events because a simple event is just an outcome. The language kind of gets in our way there a little bit, but if you think it through, I believe that you'll understand what we're talking about here. So in general, a compound event is 2 or more outcomes or simple events. Now let me just talk about language here, if you don't mind, okay? I like to be very clear in my language. Maybe that comes from my math training, or maybe that comes from being a lawyer, okay? Here's the thing. In a typical English language textbook, when you're writing something, the word or can be confusing, believe it or not. Here's an example. Let's take this sentence and really take it apart. And if you get in the habit of doing this, it will help you in the future. It will help you really understand textbooks if you understand these nuances here. In general, a compound event consists of 2 or more outcomes or simple events. Now, what is he saying there? Is he saying that it's 2 or more outcomes or 2 or more simple events? That if you didn't know the definition of the word outcome, you might think that outcome and simple events are different things, right? If you said something like, let's use a completely different example. And I think maybe the simplest example I can come up with is talking about this boys and girls thing, okay? If I were to say my brother my sister, let's say, my sister just had a child and it's a boy